Hello, welcome. We are doing section 5.5 today, which is on page 82 in your note guide. Today is 10:28 for me. We'll be doing these notes next week, however. Okay, so we're going to do a little bit of review for some of our points of concurrency. One thing I would do every time I'm doing points of concurrency and I want to know the names, I write my mnemonic device. I write Hannah, Seeker. So hopefully that helps me remember that I have 4 lines that I'm looking for when I have points of concurrency. It is a perpendicular bisector. Maybe pause your screen. Can you fill this out on your own? An angle bisector, a median, and an altitude. Okay, the perpendicular bisector creates a circumcenter. The angle bisector makes an incenter. The median creates a centroid. And the altitude creates an orthocenter. So those are what we have here. So immediately if we were to ask one of these on a test, you are going to name and give the coordinates of the point of concurrency. So as soon as you see the word median, you should be able to name that point of concurrency for me because it's a centroid up there. We already listed that. Here we have an altitude. So again, with altitude, you should be able to name that pretty immediately without even looking at anything else. So you get part of those points. So right here, median is going to be a centroid. And altitude is going to be an orthocenter. Okay, so I'm going to plot these points and create my triangle. I am at -1, -1 right here, -1, -7, and I am at 5, -1. I use a straight edge to create my triangle. Now it's nice that this is a right triangle because I can easily figure out what the medians are. The medians are going to be in the middle. So if the medians are in the middle here, a little bit of a shadow there, sorry. Exactly in the middle here is going to be 1, 2, 3, 1, 2, 3. So right here, this is the middle of that side. I'm going to draw the median from the vertice opposite of it. I'm going to draw it to that point right there. Now over here, we have 1, 2, 3, 1, 2, 3. It's going to be right here from the vertice opposite. I'm going to take this and I'm going to create this line right here. Now, the nice thing is that we should see the intersection pretty immediately. We don't even need to do the third line. You could be done right here. This would be at 1, -3. I generally like to kind of confirm that I'm in the same spot, so I would probably do the third side. And in the middle, it seems to have a slope, so you could count 1, 2, 3, 1, 2, 3. Right here is the middle of that line, and you would draw your median from the vertice opposite of that. And all 3 of those lines are definitely going to intersect at that same spot. That's one way to kind of do this with the median. Altitudes, again, orthocenter. Altitudes, another word for altitude is called height. I'm going to plot this triangle here. I'm going to go 3, 0, 3, -6, and -1, -6. So again, I have another right triangle here, which makes these kind of nice. And if you remember when we did this in the notes the other day, the orthocenter, we had 3 of them where it was an acute triangle, a right triangle, and an obtuse triangle. And if it was acute, the orthocenter was going to be inside that triangle. If it was right, the orthocenter is going to be on the triangle. So because it's a right triangle, it's going to be on the triangle. If it were obtuse, the orthocenter would be outside. So again, if we are looking just for the heights or the altitudes, and I were to start from this vertex, the height goes straight down like this. And if I flip my paper this way, and I want the height of this side over here, it's going to go just like this. They're going to intersect right here. You don't have to do the other side. If you wanted to, you could, but you know that it's got to go through the vertex, and it would be the perpendicular height, so it's going to be somewhere over here, but you don't even need to draw that. We know that the point of concurrency, the orthocenter, will be right here, which is at 3, -6. And there we go. Okay, so today's notes are going to be inequalities in one triangle. I like this sub-notes. I think they're kind of nice. They're easy to visually see and understand what's going on. So the theorem says if a side of a triangle is longer than another side, then the angle opposite of that longer side is going to be larger than the angle opposite the shorter side. So the angle on the sides are going to be related opposite of each other again. If the angle of a triangle is larger than the other angle, then the side opposite the larger angle is going to be larger than the side opposite the smaller angle. So we can see this pretty quickly with our two examples here. Write the measures of the triangles in order from least to greatest. So you definitely have to pay attention to that because it's easy to mess up and put them in the opposite direction. So least to greatest. So right here, I know that I have angle 23 is my smallest angle, which means what is my smallest side going to be? The side opposite of that is going to be BC. Line segment BC is my smallest side. So now I want to find my medium side. My medium angle is right here. The side opposite of the medium side is going to be AC. And then my largest side, because this is an obtuse triangle, is B, 111. Opposite of that, because it's the biggest angle, it's going to create the biggest side on the opposite side. The largest side over here is going to be line segment A. Oh, I wrote that wrong. AC is the longest. Across from 46 is AB. I think I said AB, but maybe I didn't. I wrote AC. Okay, so across from 46 is AB over here. Across from B is AC over here. So it's the side that's opposite. Same thing happens over here. Now we go to the angle opposite of it. So whichever one is the smallest angle is 7. We're going to go opposite of that. So my smallest angle is angle B. My medium angle here is 10. Opposite of 10 is going to be angle T. And then 11 is my largest. Opposite of 11 is going to be angle U. So that is all this is. So really, I think this is kind of a nice section. You really just have to look at the angles and the side measures, and you can figure it out. Now, the exterior angle inequality theorem, the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. So I'm going to do a kind of little drawing for this one down here. Let's say that I draw a triangle. Now, my exterior angle says if this is A and this is B, and this over here is angle Z, this right here, I know that angle A plus angle B has to equal angle Z. Oh, let's see. Okay, so here's my little drawing. Angle A plus angle B has to equal angle Z. Because together they have to equal angle Z, I know that neither of those could be Sorry, I was going to cough, and sorry I wouldn't do that. Here, I highlighted some things. Exterior angle, inequality theorem right here. A plus B has to be equal to Z, which means Z would have to be greater than A, and Z would also have to be greater than B. That's what that theorem is telling us. Now we're also going to talk about the triangle inequality theorem here. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now this looks a lot to me like Pythagorean theorem. So if you remember Pythagorean theorem, what kind of a triangle do you have to use Pythagorean theorem? And we just did it with some of our problems last week. We need to have a right triangle. And if we have a right triangle, our Pythagorean theorem is going to look like this. A squared plus B squared equals C squared. Now what is C every single time? No matter what is C? C is your hypotenuse, which is your largest side. Okay, so that we know. Now this is related to it looks similar to it. So I have to remember that the sum of the lengths of any two sides of a triangle have to be greater than the length of the third side. So if I have A plus B has to be greater than C, something like that. I'm going to say A plus B has to be greater than C. Now, the only way that this is going to work is if you make sure that C is always your largest or longest side. And as long as that's true, this is going to work for you. This is a pretty big deal. This is going to come up a lot. I'm going to go to the next page. Now here I have some triangles I want to try to construct. So I know that I have 2 centimeters, 2 centimeters, and 5 centimeters. I always forget to move in class, everybody would yell at me, Miss Miko, move your camera. Okay, so anyway, 2, 2, and 5. I want to start with the largest one first. So I'm going to come down here and I'm going to draw 5 centimeters. Is going to be like this right here. Now I want my other sides to the triangle to be 2 centimeters. Well, from this side, 2 centimeters is going to be 1, 2. It's going to be right here. Well, from over here on the right, 2 centimeters is going to end up right here. So if I were to use my compass, and I were to go to the end point here, and I knew this was 2 centimeters, my line is going to end up somewhere over here, ending at that point. That's 2 centimeters from the end point. 2 centimeters from this end point over here is going to be somewhere here. So the interesting thing here is that if I were to draw from the end point to anywhere on that arc, that's 2 centimeters. I would have to stop right here. Draw from here to anywhere on this arc, that's 2 centimeters. I would have to stop right here. Is that going to create a triangle? And I know this already because if I do A plus B has to be greater than C, and C again always has to be my largest side. 2 plus 2 is 2 plus 2 greater than 5. 4 is not greater than 5. This is not a true statement, so I do not have a triangle. There's no possible triangle here. So over here, 1 plus 1 is 1 plus 1 greater than 2. Again, no, it's not. So I am not going to have a triangle here. But this one's a little bit trickier because you can pull, why not? It's really close. I'm going to start again with 2 centimeters down here. So if I start with 2 centimeters, 1, 2, and I know from this side I'm going to have one that goes 1 centimeter to right here. And from this side I'm going to have one that goes 1 centimeter to right here. They're going to touch right here. This one's going to come and touch right here, 1 centimeter. This one's going to come touch right here, 1 centimeter. And this one is 2 centimeters. Is it going to, when they meet, push up to create some type of triangle? And it's not, because they're equal, so they lay flat on there. What I think about when I think of these is I always call it my pinball machine. Have you ever played pinball? And you have the buttons on the side and you have those little pinballs, but they're never going to meet. And if they're never going to meet that ball, you're not going to be able to keep that ball going forever because it's going to fall through the middle at some point. It's going to fall through the middle. This is where the pinball machine is not going to work. And it's not going to work here. Here, the pinballs would touch, but this is not going to create a triangle. It's not going to go up, it's going to lay flat. So there's no triangle possible here. Now over here, let's say I have a 6 centimeter side, and over on this side, I'm going to have a arm that's 5 centimeters from the vertices. So 5 centimeters is going to come out to here. I'm going to mark the 5. Now from the other side, though, I'm going to have an arm that's 2 centimeters. So it's going to come back 1, 2. It's going to go on the other side. So if I'm going to use my compass to create this, I'm going to come here to the end. I'm going to extend it 5 centimeters to here. Now if it's 5 centimeters, my arc is anywhere here. And now if I come to this side, I can create 2 centimeters, and my arc is going to be anywhere here. So I have a point where they are supposed to meet. So from this side over here, the 2 centimeter one is going to be right here. My 5 centimeter one will be here to the vertices, or to the end point. And this is my 6 centimeter. So I definitely have a triangle that can be created here, because 5 plus 2 is 7, that is greater than 6, check, that one's the one that works. So again, you do not have to create these triangles, but I like the visual to see why does it work every time. Okay, now here we have one more problem, or we have a few more problems, but triangle has one side that's 8 centimeters and another that's 17. Describe the possible lengths of the third side. So most people do this. They say, okay, well, 8 plus 17 has to be greater than the third side. And well, I know that 8 plus 17 is 25. Has to be greater than the third side. So I think if 25 is greater than the third side is going to have to be less than that. It's going to have to be 24 or something like that. But there's a stipulation here. I don't know that I'm looking for the longest side. What if 17 was the longest side? If 17 is the longest side, I would have to say, well, 8 plus x has to be greater than 17. So there's going to be a limit. There's going to be a range that we can do this with. I'm going to subtract here, and I'm going to say that x has to be greater than 9. So now I have my range. It has to be less than 25, but it also has to be greater than 9. Now, so you have two cases. We have a shortcut that we kind of use for this, so every single time we have this problem, this is what I would do. I'm going to set up my x in the middle. I want to figure out the range that I could go. So my range is going to be something on the left, something on the right. Now what I do is, because I want it to be bigger over here, I'm going to take the 8 and the 17 and add them over here. Add them on the right, I get 25. I'm going to take them over here on the left. I'm going to say 17 minus 8 is going to be 9. I added on the right, I subtracted on the left. That's it. So if you remember that, you don't have to do like different steps or different cases. You can just do one case when you're doing this type of problem. Now also remember, anytime you have word problems, you need to have word answers. So 9 centimeters and 25 centimeters. Here we have 2 more review problems right here. Write equations in point slope and in slope intercept. So I want in both of these cases to write an equation in point slope first. I'm going to put my point slope here. And then the next question, I want to write it in slope intercept. I'm going to put my slope intercept here for these lines. Now the first one, they gave me 2 points. I want to use point slope. I have a point, I have 2 points. If I have 2 points, I can find my slope. So remember, slope is your change in y's. So I'm going to start with y's up top and 4 minus negative 1. So it's a change in y's up top over the change in x on bottom. So if I start with 4, I'm going to start with negative 5 minus 5. 4 plus 1, I end up with 5 over 10. Here I can simplify this, and I get a slope of negative 1. Okay, so if I'm going to do my point slope equation, I'm going to start with my ghost formula. I'm going to say y minus equals m times x minus. And I fill in everything I know from here. Well, I just found my slope, so I'm going to say it'd be negative 1/2. Now I have 2 points. How do I decide which point to use? We generally agree in class to always pick the first point. So I'm just going to use the first point every time. Then it's going to look the same for everybody, and we're going to be able to answer it together. My y minus your y is a negative 1, so plus 1, minus 5. That is my point slope equation of a line, and I'm done with that part. If I want to get to my slope intercept, though, I have to solve this. So if I solve, I'm going to have y plus 1. Distribute, I get negative 1/2 x. Negative times a negative will be positive 5/2. Okay, now this isn't that bad. Don't worry. I have to subtract the 1. Well, I want to subtract a 1 where I can subtract it from 5 over 2. So how do I make 1 have a denominator of 2? So really what I'm going to do is I'm going to take this and I'm going to say, well, subtracting 1. But over here, when I subtract 1, I want it to be a fraction. So a fraction with a denominator of 2 is 2 over 2. I end up here with y equals negative 1/2 x. 5 halves minus 2, I get plus 3 halves. And there we go, I'm done with that one. So coming over here now, I want to do both point slope and slope intercept. So I'm going to start with my ghost formula again. Y minus equals m times x minus. I want it to be this point. So again, 6 is my x, I'm going to do minus 6. Y is negative 7 minus negative 7, so I'm going to get plus 7. Now I want it to be perpendicular to this slope. So my slope to begin with is negative 3/5. What would my perpendicular slope be? My perpendicular slope is going to be the opposite reciprocal, so it will be positive 5/3. There's a positive 5/3 in there. I'm done with my first equation. I can be done if all I have to do is write an equation, that's it. I want to do 2 equations, so now I want to put it in slope intercept. So I'm going to solve this. Y plus 7, 5/3 x. 5/3 times 6, I would go ahead and take that, and I would put that negative 6 over 1. 3 goes into negative 6, negative 2 times 5. That is going to become a negative 10. So I'm going to add 7 over here. I get y equals 5/3 x, negative 8, I get negative 17. And there we go. Okay, so I'm going to end the notes here. I'm going to do a different video for the next couple of pages. Hopefully you guys are doing great and staying caught up on all the videos and notes and assignments and enjoying the weather getting a little cooler. Have a fabulous day. I will see you guys later.